Hello, dear students. Today we have Proposition 39, Book 1, Proposition 39. Triangles on the same base, which are equal to each other, and on the same side of that base, are in the same parallels. Okay, so here we have two triangles. It's given that this triangle is equal to this triangle, and that they are on the same base, and of course on the same side of that base. Thus, it is required to show that this triangle and this triangle are in the same parallels. We're going to use a reductio ad absurdum to do that, okay? So let's connect the apexes with a straight line, okay? I say that this line is parallel with this line. For if not, some other line is parallel to this line, okay? From this point, say. So let's do that. Let's make another line, okay? Let this line be parallel to this line, okay? And not this line, great? So let's then connect our 2 points here, okay? Now we have a triangle on this base, right? And remember this triangle on this base? So here we have two triangles on the same base and in the same parallels. Remember how we proved in the past, we have in our bag of knowledge, that two triangles on the same base and in the same parallels are necessarily equal to each other. So it must be the case that this triangle here is equal to this triangle here. Great, no problem. But it was also given that this triangle is equal to this triangle. Now we have two things equal to the same thing. They're necessarily equal to each other. So this is equal to this. The whole equal to the part, but we know the whole is greater than the part. So here we have this triangle here, both equal and not equal to this triangle here. Boom, that's an absurdity. Two things cannot both be and not be at the same time in the same respect. And since that's absurd, the thing we granted that we didn't want to grant, but Mr. Smarty Pants forced us, which is good for him, that this being parallel to this, that must be false, because that leads to an absurdity, that something is both equal and not equal, that this is both equal to this and not equal to this at the same time, in the same respect. The same thing would happen over here if we took the line up here and say, okay, let it not be this one, let it be somewhere over here. Then we continue this up, and then we have this being equal to this bigger triangle, which is absurd, okay? So we have the same problem. You can work that out on your own if you want. Thus, we have shown then that if you have two triangles on the same base and they're equal to each other and they're on the same side of that base, then they're necessarily in the same parallels. Quod erat demonstrandum. Thank you so much.